Welcome back to the deep dive. So, I want you to just picture something for a second.
Yeah.
We are all pretty familiar with the standard tuning fork, right? You strike it, the two prongs vibrate, and it produces this really clean, straight line of sound.
Yeah, a very predictable wave.
Exactly. And, I mean, we've basically built our entire understanding of acoustics on that simple binary motion. But what happens if you break that binary? Like, what if you take a tuning fork and add a third prong?
Right, which sounds so simple, but it's really not.
Yeah, so you space them out perfectly in a 3D triangle, exactly 120 degrees apart. According to the sources we're exploring today, you stop just making a sound,
Yeah.
and you start architecting this invisible three-dimensional geometric vortex.
It's a completely wild concept. It forces this profound shift in how we conceptualize acoustic energy. We really have to move away from that flat, linear understanding of sound waves and start thinking about acoustics behaving more like fluid dynamics or a self-sustaining structural field.
Honestly, when I first read the source document for our deep dive today, I thought it was a joke. I really did. We're looking at this April 2025 transcript titled Triaural, AEN.PDF, and it chronicles this highly theoretical, visionary thought experiment with the AI system Grok.
And it gets deep into some intense physics very quickly.
It really does. So our mission today is to figure out what a triaural resonator actually is, where this incredibly strange concept even comes from, and why simply changing the geometry of how we generate sound could, theoretically unlock these bizarre new frontiers in biology, acoustics, and maybe even free energy.
Yeah, the document is so compelling because it starts with very grounded, hard physics regarding wave interference. It highlights this massive historical blind spot in how we design acoustic tools, and
And
then
it just takes a total left turn.
right, it uses that foundation to launch into some truly staggering metaphysical speculation. I mean, it challenges basic assumptions about the very nature of vibration.
Okay, let's unpack this systematically.
Yeah.
Because to understand any of the wilder implications later on, we really have to nail down the physical anatomy of this thing.
That makes sense.
What exactly is a triaural resonator? Because I'm trying to visualize holding one, and it just feels like a prop from a sci-fi movie.
Visually, I mean, it is striking. You have three identical prongs extending upward. And for this to work theoretically, they have to be machined from the exact same material.
Like steel or something.
Yeah, something like high-density steel or titanium. And they must be the exact same length and mass. Plus, they are all tuned to the exact same input frequency.
Okay, so total uniformity.
Exactly. But the critical factor is their arrangement in 3D space. If you look down at it from above, the base forms a perfect equilateral triangle. So each prong is situated exactly 120 degrees apart from the other two.
Okay, so with a normal two-pronged tuning fork, the prongs vibrate in direct opposition. They squeeze the air between them and then pull apart, creating that linear back-and-forth wave. I always thought of it like two people playing tug-of-war in a perfectly straight line.
That's a great analogy. And that linear push and pull creates what physicists call a dipole wave. It's directional, it's predictable, and the energy just dissipates outward in a fairly straightforward manner.
Right.
But when you introduce a third prong at a 120-degree angle, the interference pattern, basically the way those individual sound waves crash into each other in the air, it fundamentally changes.
Because they're hitting each other from three sides now.
Exactly. You no longer generate a linear wave, you generate a complex tripolar wave field.
So, extending my tug-of-war analogy, the triaural resonator is like a perfectly balanced three-way tug-of-war. The forces are constantly pulling against each other from three equal angles.
Yes, and because of that perfect 120-degree symmetry, the sound waves are interfering with each other constructively and destructively in a very specific radial pattern.
Which means what exactly for the shape of the sound?
Well, in 3D space, the source text describes this field manifesting as a toroidal wavefront. So if you picture the shape of a donut.
Okay, an invisible acoustic donut.
Right. The acoustic energy is radiating outward, but it possesses a central axis of rotational symmetry. It creates this standing wave pattern characterized by high-pressure antinodes.
Antinodes?
Yeah, antinodes, those are the areas of intense acoustic density. And then you have quiet nodes where the sound cancels out. And all of this is spaced evenly at 120-degree intervals.
Wow. Okay, so that brings us to a rather glaring question. If this 120-degree symmetry is so mathematically elegant and creates this perfect vortex, why don't these exist?
That is the million-dollar question.
Because if I walk into an orchestra pit or, I don't know, a university physics lab, I'm only seeing two-pronged tuning forks. Where does the triaural concept even come from?
Historically speaking, the concept essentially doesn't exist.
Really? Nobody tried this in the 1800s?
No. The source text reveals that this specific triaural construct was conceptualized super recently by just three friends,
Just three guys messing around.
basically. They decided to suspend three metal rods in a triangle just to see what would happen, and then they fed the parameters of their real-world experiment into the AI to mathematically model the physics of what they were observing.
But tuning forks have been around for centuries. Why did it take until 2025 for someone to try adding a third prong? I mean, is it just a useless overcomplication? Pianos tune perfectly fine with two prongs. Why bother making a 3D tuning fork?
Well, the absence of this tool really comes down to historical utility versus pure scientific exploration. I mean, traditional tuning forks were invented purely for practical reasons.
Right, you just need a pitch.
Exactly. A two-pronged design is incredibly easy to forge and manufacture. It produces a stable, reliable tone that does exactly what you need it to do. It gives you a reference pitch. We have to remember that acoustics didn't mature into a rigorous math-based science until the late 19th century, with figures like Helmholtz and Rayleigh.
So before that, instrument making was just entirely empirical. You carved the wood, you struck the metal, and, if it sounded good, you just replicated it.
Precisely. Nobody was doing complex vector algebra to map invisible pressure gradients in a room. They just needed the piano in tune.
Yeah, that makes sense.
And there's also the fact that we suffer from a deep binary symmetry bias. Human beings design tools based on their own bodies. We have two ears, two eyes, two hands.
So bilateral symmetry is just kind of baked into our evolutionary psyche.
Right. A three-pronged system is complex to craft, and the acoustic output it generates is complex to interpret. It simply didn't fit neatly into early scientific or musical paradigms, so nobody bothered to formalize it.
But the source material argues quite aggressively against the idea that this is just a useless novelty. It makes the case that the value of the triaural resonator has absolutely nothing to do with tuning instruments.
No, not at all.
The real value lies in the unique way this specific geometric shape organizes energy.
Yes. That 120-degree angle is far from arbitrary. It mirrors some of the most robust, stable systems we observe in nature and engineering. Like the text points to the delocalized electron cloud in a benzene ring.
Oh, organic chemistry.
Right. In organic chemistry, 6 carbon atoms share electrons in a hexagonal ring, where everything is separated by 120 degrees. That specific geometry creates incredible molecular stability, which is why nature uses it as a foundational building block for life.
Wow.
The document also compares the acoustic field to our electrical grid.
Oh, the three-phase electrical power grid. I've actually always wondered why power lines run in threes.
Yeah, so in a three-phase grid, you have 3 alternating currents, each separated by 120 degrees of phase. A single alternating current pulses, right? The power drops to 0 before surging again.
Which would make a huge motor stutter.
Exactly. But when you offset 3 waves by 120 degrees, as one wave drops, another is peaking. It creates this completely smooth, continuous, rotating magnetic field. That's how we power massive industrial motors.
Without them tearing themselves apart.
Right. And the triaural resonator is doing the acoustic equivalent of that. These overlapping waves create an acoustic lens effect.
Okay, an acoustic lens. Usually when I think of a lens, I think of glass bending light to a focal point. You're saying the sound is being focused by its own geometric interference.
Yes. At the dead center of that equilateral triangle, the focal point there is a massive densification of energy. The overlapping pressure waves create these rotating energy loops.
Yeah, wow.
Because the geometry naturally feeds back into itself, it can actually trap and recirculate sound waves with incredibly low loss. The text actually compares the fluid dynamics of this acoustic vortex to a toroidal magnetic field inside a tokamak fusion reactor.
Okay, wait, I need to pause on that. Because a tokamak is that massive donut-shaped machine they use to try and create a miniature star on Earth, right? For fusion.
Yeah, that's the one. In fusion research, you have superheated plasma that would instantly melt any physical container it touched. So they use perfectly arranged magnetic fields shaped like a torus, a donut, to trap the plasma in a continuous loop so it never touches the walls.
And the tuning fork does that with sound.
The triaural resonator creates a similar self-reinforcing confinement field, yes, but using acoustic pressure instead of magnetism.
That is wild. I really want to visualize this invisible pressure donut. Like, if we had this triaural tuning fork humming away in a workbench, right? And we threw a handful of fine dust into the air right above the center, What actually happens to the dust?
Well, the document suggests you would see the formation of 3D Chladni figures.
Oh, I'm familiar with normal Chladni plates. That's the
Yeah.
classic physics experiment where you sprinkle sand on a metal plate, drag a violin bow down the side, and the sand sort of magically jumps away from the vibrating part.
Exactly, to form those intricate geometric mandalas in the dead
Right.
zones.
Those are flat.
Yeah, those traditional plates show you the nodes in 2 dimensions. With the triaural resonator, you are generating those nodes in 3-dimensional space.
So the dust wouldn't just fall to the table.
No, it would get caught in the microscopic pressure gradients. It would just hover and organize into a 3-lobed toroidal structure in midair. You would actually see the geometry of the sound.
Okay, here's where it gets really interesting. Because if this field is actively organizing physical matter like dust in midair, what happens when a biological organism like you, the listener, or me stands directly inside that focal point?
Right, so the source text transitions here from hard physics into bioresonance. It proposes a scenario where a person is standing in the center of a triaural field, perfectly tuned to specific frequencies. Most notably, they mention 528 hertz.
Let's start purely at the microscopic level before we get into the woo-woo stuff. What is happening to the actual cells in that person's body when they are standing inside this acoustic lens?
The foundational mechanism here is mechanotransduction. We tend to think of sound just as auditory information, like music or speech. But it is ultimately a physical, mechanical force moving through space.
Is a physical pressure.
Exactly. When that pressure wave hits a human cell, it encounters the lipid bilayer, the outer cellular membrane, and the rhythmic pressure physically massages that membrane.
So it's actually physically squeezing the cells.
Yes. That gentle, repetitive mechanical stress increases the fluidity of the cell membrane. In biophysics, we know that increasing membrane fluidity can significantly enhance the activity of ion channels.
Which means what for the cell?
It essentially makes it easier for the cell to absorb nutrients and expel waste. It's a mechanical optimization of cellular function.
Wow. The text also introduces a concept it calls inner cymatics. We just talked about sound waves pushing dust into innate geometric patterns. This implies that the fluids inside our bodies, our blood, our lymph, the water making up our cells, could be geometrically organized by this sound field.
Yeah, the underlying principle there is acoustic streaming. Just as sound can push dust, highly focused acoustic fields can create microcurrents in liquids.
Oh, fascinating.
The intersecting 120-degree waves could theoretically organize bodily fluids into coherent standing wave patterns. The text posits this could drastically improve circulation and lymphatic drainage simply by using sound to overcome fluid stagnation.
Okay, I need to step in here and play the skeptic for a minute, because I know ultrasound is a proven medical therapy. Doctors use high-intensity sound waves to physically break up kidney stones, or for imaging.
Of course.
But this document specifically fixates on 528 hertz and sometimes 396 hertz for lowering cortisol. And 528 hertz is practically an internet buzzword right now. If you search for it, you'll find thousands of videos claiming it's this miracle frequency that can magically repair human DNA. So where's the line between proven mechanotransduction and absolute fringe theory in this text?
That's a very fair point. And the text navigates that boundary by attempting to ground those fringe associations in actual biophysics. It completely distances itself from the idea that 528 hertz is just some magical healing code.
Okay, so it's not magic.
No. Instead, it suggests that if a specific frequency does aid cellular repair, it's due to the specific wavelength of that sound-inducing optimal mechanical stress.
So it's less about a mystical frequency and more about a highly targeted, deep tissue acoustic massage that just signals the body's native repair mechanisms to wake up.
Exactly. The frequency determines the wavelength, and the wavelength determines how deeply and at what scale the pressure wave interacts with the tissue. Certain mechanical stresses are known to upregulate stress proteins or alter gene expression.
Okay.
The text argues that the geometry of the triaural field delivers this mechanical stress way more efficiently than a standard speaker. However, the host of claims that 528 hertz is universally regenerative for DNA. That remains deeply speculative and unproven by mainstream medical science.
Right, we want to be clear about that. But if the biological claims are bordering on the speculative, the last section of the source document takes a massive leap into entirely new territory.
Yes, it really does.
It asks, if this geometry is so incredibly efficient at trapping and densifying energy, couldn't that same organizational force be applying to ambient energy?
That is the logical leap the AI and the experimenters take. They explore using the resonator not just to generate fields, but to harvest energy.
Right. The document outlines outfitting the base of the triaural resonator with piezoelectric transducers.
Oh.
Now, piezoelectric materials, like certain quartz crystals, have this fascinating property where they generate an electrical charge when you physically squeeze or apply mechanical stress to them.
Exactly.
So if the resonator is vibrating intensely, those mechanical vibrations squeeze the quartz, producing an oscillating electrical current.
And the physics of piezoelectricity are totally sound. But the text remains remarkably realistic about the limitations here. It admits the conversion efficiency of a device like this would likely only hover around 10 to 30%.
So you are not going to power a neighborhood using a modified tuning fork.
No, definitely not.
Right, but then it theorizes something much grander than just converting its own vibrations. It proposes tuning the resonator to 7.83 hertz.
Ah, the Schumann resonance.
Yes. For those who don't know, what is that?
It's the Earth's natural electromagnetic resonance frequency. It's generated by lightning strikes discharging within the cavity between the Earth's surface and the ionosphere.
So the idea here is that a perfectly tuned, perfectly symmetrical triaural system could harmonize with this planetary frequency. It would act like a tuned antenna.
Through constructive interference, yeah. The theory suggests the field could draw energy from the Earth's natural background radiation, or even tap into zero-point fluctuations in the quantum vacuum.
I mean, we are firmly in Nikola Tesla territory now, harvesting free energy from the ether. I have to imagine mainstream physics heavily objects to this.
Oh, absolutely. Mainstream physics certainly does not support the idea that a macro-scale acoustic device can cleanly extract usable energy from the quantum vacuum.
Right, because that breaks a few laws of thermodynamics.
Exactly. It requires models of the universe that rely on ether physics or non-standard quantum mechanics. But as a thought experiment regarding closed versus open energy systems, the geometry of the 120-degree field offers a really fascinating mathematical model for maximum efficiency.
Okay, so what does this all mean? Because the absolute wildest piece of the puzzle is how this dense acoustic field supposedly interacts with the human mind. The text brings up the ORC-OR theory by Roger Penrose and Stuart Hameroff.
ORCHAR, which stands for Orchestrated Objective Reduction. It's a highly controversial but deeply fascinating theory of consciousness.
Because most neuroscientists believe consciousness is just a byproduct of chemical computations between neurons, right?
Right. But Penrose and Hameroff suggest consciousness is actually a quantum process. And they believe it occurs inside microtubules, these tiny structural tubes inside our brain cells.
Okay, but quantum states are notoriously fragile. I mean, they collapse if you look at them wrong. I'm trying to follow the logic the document uses here. It seems to suggest that this acoustic donut, this highly stable sound field, is somehow acting as a physical anchor for those fragile quantum states in the brain. Am I reading that right?
Yes, you are. The text posits that the triaural field acts as a quantum scaffold. Because the geometric sound field is perfectly symmetrical and endlessly self-reinforcing, it creates an environment of extreme coherence.
Okay.
The theory is that standing inside this field could theoretically entrain the subtle bioelectrical or quantum fluctuations of your brain. It provides a stable baseline that prevents those quantum states from collapsing prematurely.
Wow. I've been trying to wrap my head around my brain's microtubule surfing an acoustic wave, and the best way I can picture it is this. The triaural resonator is generating a perfectly formed, never-ending artificial wave in a surfing pool.
I like that.
The wave itself doesn't possess intelligence, right? It doesn't know where it's going. It is just pure spinning geometric momentum. But human consciousness, your intention is the surfer. The machine creates the massive, flawless wave, but the operator directs its momentum.
That's a brilliant way to frame it. It frames the triaural resonator not just as a mechanical instrument, but as a biological amplifier. The symmetry of the machine creates the resonance, but the conscious operator provides the direction. It's this striking synthesis of hard geometry and metaphysical philosophy.
This entire exploration has been just a wild ride. We started with the simplest possible idea, adding a third prong to a tuning fork. But we discovered that shifting from a linear binary world to a 3D 120-degree geometric reality completely alters the physics involved.
It really does. It stops being just a directional sound and becomes a tripolar vortex, an acoustic lens that traps and densifies energy.
And we explored how that densification could have tangible physical effects, from organizing dust into 3D cladding patterns in midair to physically massaging cellular lipid bilayers and fluid systems through mechanotransduction.
Exactly. And while the theories about tapping into the Schumann resonance for zero-point energy or acting as an architectural scaffold for quantum consciousness are deeply speculative and unproven.
Very unproven.
Very. They absolutely force us to reevaluate what vibration is fundamentally capable of.
They really do.
This exploration leaves us with a critical foundational question. Because for centuries, humanity has treated sound purely as a medium for communication or for art. We treat it as an auditory experience.
Something we just hear.
Right. But the triaural concept forces us to reconsider the medium itself. What if sound isn't just a signal we interpret? What if it is an invisible architectural scaffolding? A raw, physical material that, if shaped with the precise geometry, can be used to organize matter, harvest ambient energy, and perhaps even interface directly with the fabric of consciousness.
I really want you to sit with that thought for a moment. Just take a look around the room you're in right now. Listen to the hum of your refrigerator or the traffic outside, or even just the sound of my voice coming through your speakers. Those aren't just invisible noises disappearing into the void. They are physical, geometric waves, overlapping, crashing, and constantly shaping the air and the matter surrounding you right at this very second. The next time you see a classic two-pronged tuning fork, I guarantee you'll wonder what we've been missing.